Hello, ladies and gentlemen. All right, so this is the last one, I believe, for the organic chemistry unit. We're going to be talking about, basically, it's all about alcohols, and then also we're going to touch on combustion at the end, the two different types. There's really three different types, but two that you're going to be most responsible for. These are just the bullet points. We're going to talk about these three ways of dealing with alcohols and turning them either into ketones and aldehydes or taking ketones and aldehydes and turning them into alcohols. We're going to talk about the esterification process and how we can also create ethers from alcohols. This ethers from alcohols part, this is unnecessary information. I'm not going to spell this word right. Unnecessary info. But it's good for you to be able to see it and kind of think about it in the same way because it's very similar to esterification. And then lastly, we're going to be doing formation of alcohols through the use of halogen alkanes. So this would be something like propane with a bromine group at the end. How we can just very simply switch out that bromine for propane, or sorry, that bromine for alcohol. So preparation of alcohols by reduction of aldehydes and ketones. So it's very similar to what you're going to be seeing in a bit here. Really what we're just doing is if we add, if you pretend like you have H2 here, and I'll draw this out so that we can actually see the mechanism. Remember this R group just means a chain of carbons. And the same thing here, it's just another chain. If we have this hydrogen coming along, the first thing that's going to happen is these electrons are going to jump up to that oxygen. So we're going to have a negatively charged oxygen and a positively charged carbon, a carbocation. This hydrogen is going to create basically the same thing but reversed. So at one point here, we're going to end up with an H plus, an H minus, which is incredibly unstable and rare. So this won't last very long at all. With a carbocation and our oxygen anion. And then you can kind of just see how it's all going to pair up. These two electrons are going to grab onto that hydrogen. These two electrons from the hydrogen are going to jump onto this carbocation. And then we end up with an alcohol group where there was once a ketone. Oops, that should just be the prime. A good idea to keep in mind is remember if it's an aldehyde, so if it's going to be something that's like a C double bond O with an H to the end, we're going to end up with a primary alcohol, so an alcohol that's at the terminal carbon, the very end one. And then if it's a ketone, so this is our example here, this would be a ketone, where the double bond oxygen is in the middle of a chain, then we're going to end up with a secondary alcohol. You shouldn't ever get a tertiary alcohol out of this just because you're going to be adding in a hydrogen, and that hydrogen is not going to be counted as a substituted group. This is also, keep this in mind because when we start to talk about oxidation of alcohols to form aldehydes and ketones, it's the same process but just backwards. We'll see that very shortly here. So this is going to just be a series of examples showing you the difference between what an aldehyde does when it reduces, what a ketone does when it reduces, and then the fact that esters and carboxylic acids do not react under this reductive process. So step by step, this is our aldehyde. For the IB, you don't need to look at this and know what it's supposed to do. IB is just going to show you it like this. It's going to do a bracket with an R, which just means it's going to reduce. And then you'll see that this aldehyde actually switches into, after the two hydrogens have been added, we now end up with a primary alcohol. With our ketone down here is where I'm looking. This is our ketone group. We end up with a secondary alcohol that you end up getting the H here and an H here, which they just show as bonding up. And then now you should see that with this ester, this is the ester group that we're looking at. It once was a carboxylic acid. This does not undergo reductive. So instead of having our reaction here, we actually get a reduction still on this ketone. And we end up with a secondary alcohol. So you should see that ketones and aldehydes undergo this process, but not so much esters or carboxylic acid groups. So now we're going to look at the same thing but reverse. So this is the oxidation of alcohols. So if you have a secondary alcohol and you oxidate it, just like we saw before, it's going to make a ketone. Basically, these two H's jump off and they make H2 gas, and you end up with this ketone group because this other bond forms onto this carbon. If it's a primary alcohol, you get an aldehyde. These H's end up joining off together, and then this bond forms right there to give you that double bond oxygen. And then if we even oxidate it one more, so when we're talking about oxidating, we're talking about this carbon, we are actually able to form a carboxylic acid group at the end of this. So it's kind of a primary alcohol can turn into a ketone, and then the primary alcohol can turn into the aldehyde, and then that aldehyde can turn into a carboxylic acid group. If it is a ketone, this cannot become a carboxylic acid group. And this is just because it has a carbon chain on both sides of that double bond oxygen. Doesn't happen. This only works with aldehydes. Very important. You will see this all the time in organic chemistry when you go to university, but for us, we're just looking at the bracket O for oxidation, bracket H, or sometimes you'll see the bracket R for reduction. So this is the same idea, this idea of if we if we oxidize a primary alcohol, this is a primary alcohol right there, we can turn it into an aldehyde, and then we can take this same aldehyde and we can oxidize it one more and turn it into an acetic acid. This is what is actually happening in biological stuff. This is ethanol metabolism. So this is, I just wanted to show you what it looks like in nature. Same exact stuff that we've seen before, it's just now kind of in context in a way. This is biology, and I don't really understand biology, but I know this is what happens. Okay, so this is the ethers, the ethers. This is creating ethers. This is the kind of fun to know information. The reason why I'm bringing it up is because you need to have two primary alcohols, so alcohols that are on the terminal carbons, because what ends up happening is because water is such a stable molecule, you have an alcohol group that leaves and a hydrogen from the other alcohol group. They get together and they form water. And then this oxygen, so what you end up with is a step that looks like this, O minus, and then on the other side you have CH2, CH3 plus. And then these two lone pair electrons from the oxygen join up with that carbocation, and you end up with this wonderful ether. I wanted you to see this because this is the same exact pattern that's going to happen when we look at esterification right now. So I'm going to just walk you through the mechanisms of this. So we're going to make an ester, which is a carboxylic acid group and an alcohol joining hands together forever in peace and loving harmony. So we've got a carbon with a double bond oxygen, an alcohol group. This is our carboxylic acid. And then over here we end up with an alcohol group and a chain of carbons. This bond splits and these electrons jump onto this oxygen, creating an H+. It's an acid. Acids donate a hydrogen plus ion into the solution. We'll get to that next unit. But what we end up with is a relatively stable compound. This carboxylic acid group without the H, it now has resonance, and that allows for increased stability. So it's actually not in any danger. It's fine in this state because it has a resonance structure to give it more stability than it should have. And then what we have here is this alcohol group actually steals both electrons to create a carbocation. So we end up with a situation where we have an H plus, OH minus group, carbon, carbon, and a positive group here. These two electrons jump on to form our ester, and these two here, this alcohol and this H plus, they combine to make water, HOH. So what we finally end up with is R. This is our ester group, and then we also have our water. A lot of this is going to look very similar to things that we've seen before. It's called dehydration synthesis. It's also called condensation reaction. Really anything where you're getting water as a product and combining two things, it's synonymous with those same terms. So next up, we're going to talk about how to create an alcohol from a halogen alkane. So a halogen alkane is just when you have a halogen connected to an alkane. Halogen alkane. So it's a two-step process. The first one is we have to wait for this bond to be broken. So we need to have a bromine anion, and a carbocation. This happens fairly slowly. It does happen on its own though. And then secondly, you're going to get an alcohol group that will join onto the carbocation. Most of the time when we do this, we use something like NaOH, where it splits up into Na and OH minus. And then that just speeds the process up even faster because these two electrons jump onto the carbocation very quickly. This also can be formed with water, and that's what's being shown here. So these electrons jump over, we get this bond, and then next up we would have a hydrogen release. So now we would have an H plus, and then we still have this Br minus in solution, and they just would make HBr. This is a fairly simple mechanism because most of the time you're going to see it with an OH minus somewhere in solution. The way it's done most of the time. This is actually very easy to do. So I'll expect you to be able to do this, and I'll help you out if you get stuck. And lastly, types of combustion. Complete, incomplete, and then when it's extremely limited. So what you guys are used to seeing is a complete combustion, which is an example here. This is when you have enough oxygen to let the reaction run through normally. This is when you guys were doing your reaction types. This should have been the one you've seen before. You have incomplete, which is the one that's right here, incomplete. And this is when oxygen is limited and nature compensates by creating carbon monoxide instead of carbon dioxide. This is what happens in engines for the most part, because you have such a small area that the oxygen supply is limited that it pumps out carbon monoxide instead of carbon dioxide. Both do get produced, but I believe the majority is carbon monoxide. And then lastly, this is a way that we can actually create, it's called activated carbon. And this is a really useful farming technique, or I guess fertilization. What you do is you create this activated carbon, this fuel that was burned, and what happens is people dig a hole, put it in there, and then cover it up while it's burning, so there's very little oxygen, and you just get this activated carbon, and then that activated carbon actually can be used to start fires or spread around for fertilizer. This gets used in third world countries a lot. You guys are going to be expected to know these two. This is just bonus information that I found very interesting. They're actually using this in Puerto Rico to start to save the banana trees. So this is the last video, and you guys should have all the information you need to know after this one.